Hi, my name is Virapat Pirmanakham. This video presentation is about Chapter 2 Application Layer. Uh, Client-server paradigm. So client-server paradigm is two running application programs called process that about a client and a server. And this is a socket in application layer. So this is World Wide Web and HTTP. So now we will talk about electronic mail. So electronic mail or email allows users to exchange messages. The nature of this application, however, is different from other applications discussed so far. In applications such as HTTP or FTP, the server program is running all the time. And first, email is considered a one-way transaction. For example, when Alice sends an email to Bob, she may expect a response, but this is not a mandate. Bob may or may not respond. If he does respond, this is another one-way transaction. Second, it is neither feasible nor logical for Bob to run a server program and wait until someone sends an email to him. Bob may turn off his computer when he is not using it. This means that the idea of client-server programming should be implemented in another way, using intermediate computers or servers. So we have architecture, user agent that are sending email, receiving mail addresses, and mailing lists or group lists. MIME, MIME headers, web-based mail, case 1 and case 2. Email security. Message transfer agent or SMTP. Commands and responses and mail transfer phase. Message asset agent. POP and IMAP. POP3 and IMAP4. So common scenario about electronic mail or email. The email system needs two UA or user agent and two pairs of MTA for client and server and a pair of MAA client and server. So this is the example. So we got two UA or user agent and we got our MTA or message transfer agent. So for the explanation, it said we need two pairs of MTA. So this is the MTA client and this is a MTA server. And we got another pair of MTA like this. So and we need a pair of MAA. So like this. So we start at UA and then go to MTA client and go to MTA server. After that, it goes to spool and go to MTA client and go to MTA server by the internet and then go to boxes and go to MAA server and then go to MAA client and end with another user agent. So the user agent has two types. First is command driven and second is GUI based or Outlook. Format of an email. So for email, we have sending email or and receiving email. So this is postal mail, electronic mail. So email address. We had two parts. First is local part. Local part is mailbox address of the recipient, and domain name is the domain name of the mail server. For one email address, it has two parts of this and @ sign. Protocols used in electronic mail. So this is picture about protocol in electronic mail or email. So we had uh, three part of these. For the first is a push protocol. We use SMTP protocol, and then for a push protocol we use SMTP protocol again, and a pull protocol we use POP or IMAP protocol. So for the summary, for push protocols we use SMTP protocol, but a pull protocol we use POP or IMAP protocol. So this is SMTP commands. This is SMTP responses. This is the example show how about email works. Like this. And this is a example of POP3 that show how it works. Like this. MIME. Email can send messages only in NVT 7-bit ASCII format, or English only. Cannot send binary files or video or audio data. So this is a picture show how MIME works. And this is a MIME header to define the transformation parameters. Uh, Data types and subtypes in MIME. So this is the data type and subtype in MIME. Methods for content transfer encoding. Uh, Defines the method used to encode the messages into 0 and 1 for transport. So this is it. Base64 conversion. This is the picture how it works. Base64 converting table like this. Quoted printable. Base64 is a redundant encoding scheme. Overhead of 25%. If the data consists mostly of ASCII characters with a small non-ASCII portion, we can use quoted printable encoding. This is the picture. Web-based email, case 1, case 2. So case 1, it is only receiver uses HTTP. So we got the picture here. And case 2, both sender and receiver use HTTP. This is we got here, like this. Domain Name System or DNS. To identify an entity, TCP/IP protocols use the IP address, which uniquely identifies the connection of a host to the Internet. However, people prefer to use names instead of numeric addresses. Therefore, the Internet needs to have a directory system that can map a name to an address. So we have namespace. So it is domain namespace. Domain, distribution of namespace. Zone, root server. DNS in the Internet. Generic domains and country domains. Uh, Resolution, recursive resolution. Iterative resolution and caching. Resource records and DNS messages. And encapsulation and registrar. And DDNS. Security of DNS. Purpose of DNS. TCP/IP uses a DNS client and a DNS server to map a name to an address. The TCP/IP suite needs the IP address of the file transfer server to make the connection. The following 6 steps map the host name to an IP address. This is how it works, like this. Domain namespace. Namespace means a namespace that maps each address to a unique name can be organized in 2 ways. Flat. A name is assigned to an address. Cannot be used in a large system. Hierarchical. Each name is made for several parts. No ambiguity and duplication. Domain names and labels. So, each node in the tree has a domain name. A full domain name is a sequence of labels separated by dots. The domain names are always read from the node up to the root. So we start from the bottom to here. And FQDN or fully qualified domain name. A label is terminated by a null string. PQDN, partially qualified domain name. A label is not terminated by a null string, the same size as the client. So this is example. Domains. A domain is a subtree of the domain namespace. Hierarchy of name servers. Distribution of namespace. It is very efficient and also not reliable to have just one computer store such a huge amount of information. Hierarchy of name servers. The solution to these problems is to distribute the information among many computers called DNS servers. A root server is a server whose zone consists of the whole tree. A root server usually does not store any information about domains but delegates its authority to other servers. A primary server loads all information from the disk file. A secondary server loads all information from the primary server. Zone. So this is example of zone. See, in the complete domain name hierarchy cannot be stored on a single server. It is divided among many servers. The server makes a database called a zone file and keeps all the information for every node under that domain. We can define a zone as a contiguous part of the entire tree. Generic domains. DNS is a protocol that can be used in different platforms. In the Internet, generic domains, country domains, and the inverse domain. The generic domains define registered hosts according to their generic behavior. So this is generic domains. So Generic domains label. These labels describe the organization types. So we got com, commercial organization, edu or edu, educational institutions, gov, government institution, and org, non-profit organization. Country domains, two-character country abbreviations, US, DHKR, or anything. Second labs can be organizational, national designation, like this, for country domains. This is a recursive resolution. Mapping a name to an address is called name address resolution. DNS is designed as a client-server application. A host that needs to map calls a DNS client called a resolver. The resolver accesses the closest DNS server with a mapping request. A resolution can be either recursive or iterative. Like this. Iterative resolution. Reduction of this search time would increase efficiency. DNS handles it with a mechanism called caching. The server marks that response as unauthoritative. If a server caches are mapping for a long time, it may send an update. So it is a picture of iterative resolution. DNS types. So this is a DNS type. DNS message. Like this. To retrieve information about hosts, DNS uses two types of messages, query and response. Same format. This is the example. For summary, applications in the Internet are designed using either a client-server paradigm or a peer-to-peer paradigm. In a client-server paradigm, an application program called server provides service and another application program called client receives services. A server program is an infinite program. A client program is finite. In the peer-to-peer paradigm, a peer can be both a client and a server. The World Wide Web is a repository of information linked together from points all over the world. Hypertext and hypermedia documents are linked to one another through pointers. The hypertext transfer, or HTTP, is main protocol used to access data on the World Wide Web. Electronic mail is one of the most common applications on the Internet. The domain name system, or DNS, is a client-server application that identifies each host on the Internet with a unique name. Thank you for listening.